Hello guys, my name is Mümün Keser from Futurely. Today we are going to look into a quick tutorial about VEX inside Houdini, and let me show you firstly what we are going to do in this tutorial. So it's going to be introduction for VEX. So we will be covering what VEX is and how it's function, and also we are going to produce this kind of a pattern generating small script that can be adjusted very freely. So let me go here, show you inside here. You can do different kind of stuff, and this is also a surface operated system, which means you can use the exact same script on top of different geometries. It is a rather small script, but it will show you how to kind of produce this amount of complexity with this little bit of expressions, bundle of expressions. Alright, let's jump into it. Open a new file and start. So, what is VEX, or what does it stand for? VEX is like programming or scripting, and it has similarities to C or C++ coding languages, but it's not that, how should I say, it's not a fully scripting language or a full scripting language, because VEX, as the name also tells, it contains this word called expression. So each line in VEX is an expression. And if you followed my other courses, you might have tackled into some of these expressions, because we are constantly using expressions inside nodes, inside different nodes, and all these expressions are only one-line VEX expressions. And here inside Houdini you have wrangles where you can kind of bundle a bunch of expressions together with different functions and create this kind of a, how should I say it, little plugin or little tool for your procedural workflow that it can help you with different kind of procedures. And this is why VEX is so powerful, because you can do so much stuff in a very short amount of expression lines. And today I will be just trying to kind of help you out to understand VEX a little bit better, in order to kind of do your own stuff in it and also have the opportunity to play around as well. So let's start with always the same thing. First we have to build up a certain system or a certain workflow, and this workflow always starts with a geometry node or a network. Here let's call it Houdini introduction 002. And of course, please, if you didn't do it, check also out the first tutorial where I explain more interface and other kind of stuff. It's pretty necessary, or it's pretty important for this part, because I'm not covering that part anymore. You will find the link down below in the description for that. And yeah, so the procedural modeling technique here is pretty basic. We start always with a base mesh, which can be any kind of mesh. In this case, I'm going to use box. And here, I'm going to change the primitive type to polygon mesh, set the size here in Y direction to 2, make it a little bit higher. And also I'm going to set the axis divisions 5 for X, 5 for Z, and 10 for up. Or let's say 10 here, or 20 here, 1 to 10 here. So let's give it a little bit more mesh faces or primitives. So what I'm going to do now is I'm going to kind of select one side of this cube for the further changes. So this is now the start of a procedural modeling. Let's kind of cluster it and tell it, select this, go to this sign, and it automatically creates this kind of box. Say base mesh. Okay, now the second part. Here we will prepare our geometry for the main phase. So this is the second part of this system. And here, again, we are going to prepare the model, select the faces that we want to manipulate or change, and then go further with them. So for that, I'm going to use a group node. Call the name site. Leave it by primitives. Disable base group. Go to keep by normals and set the direction to 1 like this. Actually, it suits well, and go down with this number. So it selects only the faces that has the normal towards one direction to, or towards the Z direction. So if I change this one to other side, it will change also the selection. What I'm going to do now is I will divide this part. Here I'm going to disable this convex polygons and enable breaker polygons. And if you go down now with the size numbers here, 0.01, 0.01, 0.01, you will immediately see it had divided all the faces or all the sides. So what I have to do is I just have to define the group that I want to divide. So it only divides this part that we selected here inside this group. And at the end, what I'm going to do is I'm going to split them based on the group. So this split node, I can just kind of define the group that I want to split, and then I would have 2 outputs. The first output is the selected faces, and the other output is the other ones. All right, so now it is done. We prepared our mesh to deform. The only thing that we need is the group for edge, because if we deform now this surface, we can actually, let me show you. We can now merge them both together and we will have the same mesh again. It is still split up here, but we can then fuse them together as well, so it will be one mesh again, like we had before we split them. But if we now, for example, let's add a mountain sub here, or mountain node. If we deform this one, as you can see, it is not attached anymore to the box. So this is why we have to kind of make sure that the edges don't deform with the whole model. So the mesh is still attached to the box. So for that, I'm just going to add another group node. Set the group name to edges. Leave it by primitives, or we can actually go to points. Let's make a point group. disable this one, go to include by edges, and enable unshared edges. So we will select our edge points as a group, and here we can now go ahead and select this edges node. And then here, as you can see, it only, if you do it like this, it will only deform the edges now, which we don't want to do actually. We want to flip that or invert that. In order to do that, we just need a call sign before the group name. Then it will leave the edges alone and it will deform all the other points. And as you can see, it is still attached to the box and works fine for us. Alright, so now we made this part. What we also want to do is make sure that we have normals. Now we have normals in default, but if you kind of import another model, you might have some problems with normals, so you have to recalculate them. So that's why I always add a normal node before and set it to point normal, because we are going to deform it by points. So that's why it's important to set it to point normal. So if you go here to display normals, you will immediately see it works fine. Okay, let me just delete this mountain node and also kind of cut this line here. If you press Y and hold, you can then activate this cutting tool, and this way you can just cut connections. Alright, now we prepared everything for the deformation part. So this was the preparation part. Now let's go ahead and dive into VEX. Alright, so if you want to create some expression bundles, so VEX bundles, you need wrangles. So if you dial in wrangle, you can see there are many different types of wrangles. So what I mostly use is attribute wrangle, which is also for point primitive vertex wrangle. So if you go ahead and select attribute wrangle, you can immediately see you have different type of options, like group type. If you have groups, which we have, so let's just connect this to the first input and select side. Or no, we don't have to actually select side. You have to select edges, like we did in mountain sub, call sign before edges, in order to exclude all the edges. Then group type, I just do it by guess from group, but if you want to define it, you can just set it to points, which is a point group. As you can see here inside info box, point group edges. And then what we also have is run over, detail, primitives, points, vertices, and numbers. And since we are going to do point manipulation, we need points. But if you have, for example, some primitive operations, you have to change it to primitives. If you don't, then your code might not work that properly. And here we have this, as you can see, VEX expression, and we have this really dark box where you can dial in the code and so on and so forth, or the lines of expressions. Alright, so how does VEX work? So VEX has many different kind of inputs. It works like a point swap that we also learned in previous courses, and also in the next course we will also do some VOP stuff as well. So VOP is like VEX, but they are operators. The main difference between a VOP and VEX is VEX functions with expressions and VOPs functions with operators. So VOPs are like Grasshopper. It works with components, or better said with nodes. It's a node-based scripting or programming method or system, and VEX is more like code-oriented system, so or expression-oriented system. And here you have to kind of tell on each line what it should contain. So there are, for example, constant values, which is similar to VOP's constant values. And you, as a constant value, works like this. First, you have to define what kind of a value is that. So there are many different values: integers, floats, or vectors. It can be vector 3D 2 or vector 4. Normal vector is vector 3D. Or there are also many different types of, how should I say it, matrix and all these kind of things. In our case, in the start, it's important to know how you can set this kind of a constant value. So first of all, again, you have to define the type. So for example, integer. Then you have to dial in the name, like my constant value. And then equals to, here you have to define, okay, you set up now a constant inside this VEX. What is this constant, or what kind of a number is that? And here you can just say, for example, 2. And this value will be always 2. Or it can also be at ptnum. So it can also, so the constant values are based on the pt number of the points, for example. So when you go to geometry spreadsheet, ptnum is exactly here, this left column. And for example, if I do something like this and say, okay, now I have a constant value, you can also create attributes inside VEX by, if you for example go to info box, and here we only have normal and p as point attributes. So you can bring attribute inside VEX by only dialing in at and then the name, and now this vector is inside, or this vector attribute is inside your expression lines or inside your wrangle. But if you dial in a name which doesn't kind of which isn't equal to another attribute name, then it will create a new attribute based on this name that you dial in. For example, here new at, so a new attribute equals to my constant value. And again, as I told you, each line is an expression. That's why you have to end each line with point and comma. So you kind of setting a point or setting a closed line at the end with point and comma sign. And as you can see, it automatically created this new attribute, and it's based on the value that we created here. And again, when you create a new attribute, or if you want to really have a nice workflow, you can also, given the first number, for example, you can also define the type of this attribute as well by dialing in the, for example, I stands for integer, I at new attribute, or I at name of the attribute. It will create an integer attribute. If I dial in F, it will create a float attribute. On default, it is set to float. So if you want to do, for example, a vector, you can dial in V, and it will create a vector attribute. So this is how how it mainly works. So setting up mostly constant values, and this value can also be something like, for example, there are functions inside a VEX, like for example point function, or like remove prim. I can dive in the name. Remove prim. As you can see, functions have always this f before them, or at prim, or at point, or these kind of different type of functions. And you can find the whole list when I press F1. I think I also covered a lot of help stuff. You can open the help center here, Houdini help center, and here you have got lots of documentation about these kind of stuff. For example, if you go here and, for example, let's add point function, open bracket, you will see immediately, okay, let's select it, open brackets, and immediately you will get info node where it says what you need for this function to work. But what you can also do is click on top of the name of this function and press F1, and it will automatically open the window where it explains what kind of a function is that, what it does, and how you can make it work. So in this case, for example, this function returns the attribute value if the given detail primitive blah 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 and has the given attribute or 0 empty value otherwise. So here, for example, if you have point, it works like this. So it's a point function, you need geometry, attribute name, and point number. You can copy this and paste it here, close bracket, or after closed bracket, point comma to finish the line. And here, the first input is always the geometry. In this case, if you see something like this, let's keep this thing open. So it is the main geometry. So that means what we need here is, okay, which input is that? So where do you want to get this point attribute from? So that's why, let me just change this to vector. So this geometry or this input is equals to the input source. So in this case, we have to check out where is our connection. So in this case, it's the first one, and it's like it's like most of the scripting languages, the first input is always starting with 0. So that's why if we have this first input, we have to dial in here, for example, 0. Okay, we define now the geometry that we want to pull attribute from. And then here we have a string, and the string is mostly is regarded as, okay, here you have to now kind of dial in a word. And this word is mostly representative for the attribute name or attribute type. And you can do this input by giving, for example, inside quotation marks, you have to dial in now the name. For example, I want to pull in the normal attribute from this input. So that's why I dial in the n. And here now we need the point number, and which is at ptnum. So ptnum is a integer, and as you can see, we need an integer input here. So there is also this point attribute where the name is p, so you might somehow think that you have to dial in at p or something like this. But if you do it like that, you will then dial in the point attribute, which is a vector attribute. That's why it won't work. We need an integer, and that's why we have to dial in the point numbers. And for that, the attribute name is on default, it's always like this, at ptnum, if you want to use all the points. So this is now working. As you can see, we don't have any issues at all, and this is how it, this is the way how this kind of a workflow functions. You can always check out how it works or what I have to do, and even here you have a base info about this function that you are dialing in. So reads a point attribute value from a geometry. Okay, so now let's go ahead and build up this whole system that I showed you earlier. And while building it up, I will explain it further. So first of all, what we're going to do is we are going to use two inputs. So this workflow is also a part of the second installation of generative design course that we launched a few days ago, or better said, weeks ago. So I'm just going to show you how the core of this script that we do on this course works here. So in order to help you out. So if you are preparing for that course, this tutorial is really crucial. And if you are also not participating in that course, in the second installation of generative design, feel free to join us where we do more with this script. All right, so here in the second input, I'm going to dial in some attractor points. So for that, I'm just going to do ISO offset. And with ISO offset, you can kind of create a volume out of any kind of object. I'm going to up the uniform sampling divisions and then scatter points inside it. And the scatter values should be, I don't need 1000 points, I need only 16. Let me display the points here. And let's set the global C to something like, I don't know, 5+3 sounds nice. And let's use this point as the second input in our wrangle. So what I'm going to do first is I want to kind of calculate the distance between all these surface points and my scatter points in order to kind of create a value based on this distance. So how can we do that? So this is really, how should I say it? First, we have to make sure that we have these points inside our wrangle, because here, this wrangle now contains all the points from this surface, right? If you go to middle mouse click on the icon or info, we have already got information about all these points from the surface and primitives and also attributes. So that's why we have to now bring also all these points from this second input also inside our wrangle. It is maybe connected, but it's not in our expression, so we can't use it directly like these points that we use with normal ptnum attributes and so on. So we have to bring them in. So in order to do that, first we have to define the number of these points by dialing in an integer value or variable, as you might call them. So here I will call them, for example, position number, or let's say a position number. So attractor position number equals to, here there is this function called near point. So our position number near point, so finds the closest points in a geometry. So this is our basic function for that. Open brackets. Here you will see immediately what we need, geometry and the vector pt. So our geometry is the second input, so we have to dial in the number 1. And the attribute name, or the attribute, vector attribute that we are searching the distance from, is the @p from this input. Okay, now we have all these position numbers. What we have to do now is we have to bring also the points inside as vectors. So for that we have to create this vector value. Now rpos, so attractor position, and here we can use exactly this point attribute like I explained before. Now we have to define the geometry. The geometry is the second input, so 1. The attribute type, or the attribute name, is in quotation marks p. And the numbers are here that we created before, rpos_num. So the reason why I didn't use now the @ptnum is I don't need the point numbers of the surface points. I need the point numbers of the scatter points that we created here. So that's why I have to use that name. All right, now let's calculate the distance value between the scatter points and our surface points. And this is really easy. You only have to create this float variable or float value. Give it a name like dist or distance. Let's call it dist, equals to distance, so distance function. And here we only need 2 vectors where we calculate the distance from. So in our case, it's the @p, so our point attributes of the surface, and the newly generated vector apos. And let's create also attribute with the name @dist equals to this value dist. And if you now go to info, you will see this dist. If you click now on the name, you will immediately see that it worked pretty fine. You can open a visualizer also here that I also explained in the previous tutorial. You can also, if one of the visualizers is activated, you just can go here, click on top of it, and it will also go away. Or with right click, you can also disable it here. All right, perfect. Now we have our distance attribute or distance value that we can work from. So this is a really basic way to kind of visualize stuff. And you can also define a color attribute inside Wrangle as well. So @cd equals to dist, for example. You can also visualize it inside Wrangle as well. Here now it is black and white. If I change it to point R, so if I only change the R values, so red values of this color, you can also do it as well. So I'm also going to multiply this one with some higher number, like 2. Give it a more visualization stuff. So here what I did was, based on different attributes, if you go now to, let's go to geometry spreadsheet. Here we have our distance, right? And our color value now, or point, whatever. And our color attribute is like a vector. It is a vector attribute, which contains 3 columns. And now here, as you can see, I only changed R by using point R. You can do the same thing with point as well. If you only want to change, for example, the X values, you can only dial in @p point R X in this case. So I just want to mention that as well. All right, so let's go ahead and build up now our displacement part. So this was the part where we calculated all the distances. So I'm going to just give in some comments. So with backslash, double backslash, you can give in comments inside Wrangle. And let's call it distance calculation and this attribute slash value creation. Here we visualize it, setting up color attribute, creating this attribute. Oh, I have to comment it. All right. So now what we have to do is we have to set up setting up the displacement. All right, so first of all, what we have to do is we have to create a value called displacement. And this displacement should be equal to the magnitude of the p-values. So it should contain all the p-values as a, how should I say it, as a base value. And and on top of this base value, we are going to build up the calculation and displacement value. So let's go ahead and do that. So a float value with the name disp for displacement. And this displacement should be equal to the length function, so length of at p. So let's check out what this length does. Select, go to the name, press F1, returns the magnitude of a vector. And we have to, of course, close the expression with point, comma, always. Just make sure if something is not working, it's probably because of this or because of the brackets. Just make sure you always properly open and close brackets and also close the expression with point and comma sign. So now what I'm going to do is I want to manipulate this value with some different inputs. So I can now dial in the name disp, and it should be not just equal to a certain stuff, but with multiplication sign and equal, I can immediately multiply this value with certain things. So instead of dialing in disp equals to disp multiplied by blah blah blah, you can just dial in disp multiplied by blah 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 equals to, with only multiply equals to sign. Or you can also do it with plus equal or divided equal and this kind of stuff. So this is a way to kind of optimize your expression line. Now, what is also pretty nice inside Wrangle is you can also set up channels or parameters inside Wrangle. And there is this function called channel, ch. And as you can see, if I dial it in, there are many different type of channels. And what this channel does is, if I now, for example, dial in channel F, so a float channel, open brackets, here you can see, okay, what kind of a name does, or string channel, which means, okay, this is a channel, what is the name of this channel? But it already knows what kind of a channel this is. That's why we don't have to define the type inside here. So you can just, in quotation marks, you can just dial in the name, for example, this scale, close the brackets, close the quotation marks, and close the line with point and comma. And if now it didn't do anything, because we have to activate this channel, for that you have to go here on this sign. As you can see, create spare parameters for each unique call of CH. So if your code or if your expression lines contains this type of function, this icon will immediately create a parameter for this channel. So if you click now here, you can see it created with the name this scale a channel or a parameter here. What you can change based on different values. So now what we want to do is we want to extend that. We don't want to use only one channel. We also want to multiply this whole thing also with a sine, which is driven by displacement itself, also this point itself, and also multiplied with the distance value. So it is not the same everywhere. Based on the distance, it goes up or down. We won't see anything yet because we didn't set up the whole thing yet. So sine, there are also cosine or arcsine or tan, or all these mathematical functions are also included here. You only have to go to the help center and see where is what. For example, let's press on the name F1. As you can see, it returns the sign of the argument, and there's sine h, cosine, tan, arcsine, and also many different type of mathematical functions, which is also which is also contained here in this math functions inside VEX. So if you have any kind of, if you want to do some certain stuff, you can just go ahead and check it out here, how you can do it and how you can use it. For example, here you can also use a different type of mathematical function. And also there's this trigonometrical functions, many different ones. So feel free to play around here, and this displacement value, you can change it the way you want to change it. You don't even have to use this kind of distant calculation. You can also use a different attribute, but we are going to talk about it later. So let's build up the whole thing first. So what I want to do now is I want to use this displacement that we created here and modified here in order to drive a certain manipulation or surface deformation. So for that, now I will use at n, so the normal attribute, and manipulate my normal attribute as well. And here I will multiply my normal attribute with, first of all, the disp value that we created, and I'm going to multiply that with channel, but this channel should be a ramp channel. So you can also set up ramp channels, open brackets, and the ramp channel needs more than just a name. First of all, disp ramp as the name, and it needs the values that it should kind of put into this ramp. So I will use the disp values. So this is basically it for the normal manipulation. So let's go ahead and click on this icon. As you can see, it created this ramp that we can kind of change now based on our personal preferences. for example, like this. It won't show anything yet because we are not done yet. And at the end, I'm going to use this normal attribute to deform the point position. So to do that, you just have to dial in the point attribute plus equals to at n. So as direction, I would choose at n. This is manipulated at n. And also have a multiplier here, another channel with the name displacement height. And now if you start to change all this stuff, you will immediately see that it works pretty fine and starts to displace all the stuff based on the set expressions. And now you can just play around with, for example, the ramp, make it a little bit much more interesting here and there. And you can also change the resolution of this by changing the size of the division, or also you can just add at the end some metric blur or something like that. But this is a pretty basic way to kind of create this kind of a displacement method for your geometries. And now we have as driving force, for example, the scattered points. What you can also have is another geometry. Can it be, for example, let's add a cube or a box. It's actually a box. I'm going to rotate this a little bit here and there. Just make sure it kind of intersects our geometry, for example, here. And we also have to have polygon mesh in order to have much more points. And let's add this as second input. And as you can see, it checked out all the, let me just dial down with the displacement height so we can see it better. So for example, I can scale it down, it changes the whole appearance of that. And now we have our division size is not that high. If you go higher, then you will see much detailed the displacement and much better. And let's also, for example, rotate it here a little bit and all this kind of stuff. You can also use completely different type of attributes. For example, you can with attrib from map. This is a useful component. You can dial it in, for example, here. Use a texture. I'm going to use any kind of thing would work, but we have to calculate the UVs first. So UV project, I think. No, this one. UV project. Go to initialize. For example, this image. And instead of here the distance value, you can just use, for example, the color value that you bring in here at CD. And as you can see, it displaces also based on colors or different kind of stuff. But here I have to define also. You have to be careful because in a float variable, you can't just import a vector variable with 3 columns or 3 values. You have to define one of them in order to make it work properly. Let me just filter this a little bit. Image settings, scale it up and down. And as you can see, it can also work with that as well. So it is a basic displacement, but there are many different layers to this one, and there are many different ways to use it. Distance. No. But it's a pretty quick way to come up with this kind of stuff. And you have really a lot of control over. And you can, since we are using the normals, you can also go ahead and displace also this box that we have here as well. But you have to go up with the division size in order to make it look better. Now our height is a little bit too high, apparently. You have to go down a little bit more. Or you can use this script to add complexity to your surfaces pretty easily. So this is a really quick way to kind of create a bunch of stuff or many different stuff. I encourage you to really play around, create some stuff. And in the description below, I'm going to upload this file. You can find the file, a link to this file of this tutorial. And really, again, I would like you to really go ahead, use this tutorial not to just redo everything that I did. Play around with it, bring your own meshes inside it, and kind of create crazy stuff and have fun. If you want to dive deeper into this topic, please make sure to check out our courses at the Futurely site, where you can again find the link to the Futurely site, also in the description below. You can check out the courses there, and if you're interested we would be really thrilled to see you there. And this whole script, it was, how should I say it, the core of the next generative design course, Houdini for Architects 2 course that we launched a few weeks ago. So feel free to join. We will be really super happy and thrilled to see you there. If you have any questions or anything, just make sure to leave a comment, and also you can just ask your questions at any time in DMs, in Instagram, or here in the comments. Just feel free, never be shy about this. And yeah, if you don't want to miss any further or any future tutorials and freebies, just make sure to subscribe to this channel and also click on the bell down below. I'm Mümün from Futurely. Thank you for coming by, and take care.